So here I have some code that detects the rising and falling edges of a button press. So here at the top, I'll go through this quickly. We are setting an integer that is the button pin as pin 16. This is different than what we use today, but I'm using a different board, so this will work. And I'm setting this to const, which means constant, which means that this variable is not variable. It's not going to change. It's constant. Under this, I'm setting a boolean, which is the bool keyword. Boolean is either true or false. It's a binary value. So I'm setting last button state to false, and just to initialize it so we can use that variable later. And here in the setup, I'm initializing serial, which we haven't talked about yet, but that lets me write stuff from the Arduino to the computer so we can see when buttons are pressed. Then I'm setting pin mode, which means that we are initializing a pin on the dev board, and I'm setting the button pin to be an input, and it's going to include a internal pull-up resistor. And here in the loop, I have just a little bit of code here that detects the rising and falling edges. So first, we are going to check if the button is pressed. If this digital read of button pin is low, actually I need to change that. I'm going to put an exclamation mark before digital read, which means if this is low, rather than if I didn't have that exclamation mark, it'd be if this is high. So that exclamation mark just inverts the signal, or it's like a NOT gate on the signal. And then inside of this, so if the button is pressed, we're going to also check if the last button state variable is also low. So if the button is pressed and it wasn't pressed before, if this is new information, which means the Arduino has not detected that it's been pressed, and this is the first time it's seeing that information. So that's what this last button state variable is. And because now that the Arduino has seen that the button has been pressed, we're going to set that to true so it doesn't detect it over and over again. It's only detecting it once on the rising edge. And then we're going to print to the console, the button has been pressed. And then similarly, if the button is, so this is if, this is else. So if this is true, it'll run this code. If this is not true, it'll run this code. That's what the else means. So if the button is not pressed, then we also check if last button state is true, which means it's the falling edge. It just got, the button is now not pressed. This is new information. We haven't seen this before. So we're going to set that to false, acknowledging that we have detected the falling edge. We're not going to detect it over and over again. And then simply print that the button is no longer pressed. So if I upload this, okay, it's been uploaded. Now I'm going to go to Tools, into the serial monitor, and I'll click that, and that'll open the serial monitor here. And now I'm going to press the button. And then I'll unpress the button. So you can see when I press the button, we got a whole bunch of these messages that say button pressed, button unpressed, button pressed over and over again. And then when I unpressed it, we got one message. This is because the button bounced a whole bunch of times. And we can see that on the scope when we put this on the oscilloscope. It's bouncing over and over again, and it looks like we have timestamps here that these serial messages arrived. It looks like they're all within 10 milliseconds of each other, which means that it's very quickly, a very quick bounce over and over again. And then when we lifted the button, when we unpressed the button, we only saw that once because it didn't bounce on the way when the contacts were lifting off of each other. Because they weren't hitting each other, they were no longer hitting each other, they were getting lifted off of each other, which isn't going to bounce. So how can we get rid of all of these bounces in the code? Because they're all 10 milliseconds or less, the bounces are between each other. So I'm going to drag in a new sketch here that I have debounced. And let me remove the board manager. So here's some new code, and we'll compare it to the old one. So first of all, we're initializing some more variables. I've got the button debounce time, which is the number of milliseconds that it's a constant. It's the number of milliseconds we'll set the debounce time to be, which is going to be how long after every rising edge we'll extend that pulse in the code. Then we have a button state and a last button state. We had last button state before. Now we're going to include a button state variable. and we're going to initialize this as false. It's also Boolean, which means it's binary. It's either 1 or 0. It's either true or false. And we also include this button timer, which will initialize at 0. And this will be the number of milliseconds that we can use throughout the code as a marker. Like this is a time marker. Our setup is the same as before. In the old code, we've changed this little section with the digital read and the exclamation mark, and we've moved that up here to our debounce portion of the code, and we've changed that to button state here in the old code, which is still down here. This section is all right here. So let's take a look at this debouncing section. We're going to see when the button is pressed, just like we were before with this little section of code. And when it is pressed, we're going to set button timer to millis. Now this millis function gives the current number of milliseconds since the Arduino started. So it's basically a time marker because millis is always increasing over time. So button timer is always going to equal the millis at this instant. So let's say the button was pressed at 100 milliseconds into the program. Button timer is going to be 100 milliseconds. Millis is going to keep on increasing. So button timer is always going to be 100 milliseconds. This could go to 112, 113, 114. It's always going to keep increasing. And then button state is going to be true because the button is pressed. We can say it's pressed. It's been pressed. Even if it bounces, it's been pressed. When the button bounces, we get a button pressed and we get a button unpressed. That's because it makes the initial contact, and then it bounces and lifts off. So that's where we get this unpressed. What we want to do is take this unpressed and see if that's within the last, in this case, 100 milliseconds of the first press. And if it is within that 100 milliseconds, we're going to ignore it. So we are only checking for button unpressed if we've waited at least 100 milliseconds since the last press. And that's what this does here. If the button timer, which is that initial press in the millis, in milliseconds since boot, if that button timer added with the debounce time, so 100 milliseconds more than the last button press, if that is less than the current millis, what we're saying here is the time marker from when the button was initially pressed plus 100 milliseconds is less than the millis, then that means we've actually gone past that 100 milliseconds marker, and we can stop ignoring button presses. And that's when we set button state equal to false, because the button has finally been lifted and we can verify that this is true information, it's not bounciness. So if this was within that 100 milliseconds, a button timer would be something like 200 milliseconds. We would add 100, so that'd be 300 milliseconds. Let's say millis is 250 milliseconds, which means that it's within these two. We're going to ignore that because it's likely a bounce. And then with this button state, this is our button value, like we would get from digital read, but this button state variable has now been debounced, which means it's not going to have that bounciness anymore. So we can put that right into here, and we don't need that that exclamation mark because we've already used it here. So let's upload this and see if it does anything different. Okay, I'm back here in the serial monitor. I'm going to press this button over here to clear it. Then I'll press our button. Ah, there we go. Only one console line for every press and unpress. It's no longer bouncing. Even if I go really fast, it's still accurate. Let me clear that again so you can see. And one thing you'll notice though is that it's not as responsive. You can see if I click this fast, it's taking 100 milliseconds to unpress. And so my thought is that 100 milliseconds is probably longer than it needs. That might make this not as usable. So I'm going to try something like 10 milliseconds, and we'll upload that. Okay, I've uploaded the new sketch with 10 millisecond debounce time. I'm going to clear this. That's better. You can see it's a lot more responsive now. Okay, that's it for this video. Thanks for watching.